What's going on, everyone? In this section, we're going to go over Ethernet technologies. So we start our layer 2 section with Ethernet because this is going to be the standard in technology that is used to transmit on the data link layer and the physical layer. So coming off our layer 1 videos, you might be like, oh, come on, we're tired of learning about Ethernet. But this is getting more into the layer 2 technologies, right? Getting away from the physical transmission mediums and into the actual Ethernet, the 802.3 standard in technology. So let's begin. So Ethernet is the most widely used LAN technology today, meaning Ethernet is the standard and the protocol we use to transmit data via layer 1 and 2. So again, Ethernet is going to operate in the data link layer and the physical layer. And it is a family of networking technologies that are defined in these two IEEE standards, okay? Then it's important to note that Ethernet supports data bandwidths of 10 megabits to 100,000 megabits. So even when, like, a lot of people think Ethernet just means copper, but fiber also goes by Ethernet standards as well, where we see a lot of our fiber speeds, or our fiber optic speeds. Let me get this pen out of the way for you guys. Our fiber optic speeds also go based off Ethernet as well. And as you can see here in this photo or this diagram to the right, we're going to show you how Ethernet at the layer 2 or the data link layer, right? This is layer 2. It's actually separated into two different what we call sublayers. Now, typically when you talk to network admins or someone in the IT field, when you say layer 2, they automatically think MAC addressing. And that's because typically on an enterprise, you're dealing with switching issues and frame forwarding, which is all about the MAC address, right? But the actual data link layer has two sublayers. This upper sublayer is called LLC, and then this bottom sublayer is MAC, Media Access Control, right? So, and then LLC is Link Logical Control, right? This sublayer is actually very important for the encapsulation from our layer 3 to layer 2. And so we're going to talk about that first because it's kind of the one that's unknown, right? I've talked to a lot of CCNA, even CCNP certified people that when I bring up LLC, like, don't you need that to start a business? No, yes, but no, we're talking LLC in the terms of data link, right? And again, LLC stands for Logical Link Control. And this is going to be software based, but let's go ahead and dive right into it, right? And as you can see, LLC is defined by 802.2, and then the MAC Media Access Control physical layer is defined by 802.3, but it's all Ethernet. Okay, so let's dive right into the LLC sublayer. So the Ethernet LLC sublayer is going to handle the communication between the upper layers, and we're talking OSI model, and the lower layers. So this is between the networking software and the device hardware. So the LLC sublayer takes the network protocol data, which is again like a IPv4 packet, and it's going to add control information to help deliver the packet to the destination, meaning it's how we encapsulate that IPv4 packet into our frame, right? So the LLC layer is used to communicate with the upper layers of the application and transition the packet to lower layers for delivery. So an important thing to know with LLC is that this is implemented in software. So the LLC sublayer is going to be, think of the drivers for your network interface card, right? That NIC is used on the computer or endpoint to connect you off to your switch or to your Ethernet cable, right? Your RJ45. Think of LLC as the software drivers you need for that NIC to function properly and actually send packets, right? So again, LLC is implemented in software, very important to note, because that NIC driver is going to be the program that interacts directly with the hardware on the actual NIC to pass the data between the MAC sublayer, which we see right here, and the actual physical transmission medium. And again, kind of see with this diagram, Ethernet encompasses these two layers, but as we can see here, IEEE 802.2 is going to cover the logical link control sublayer, and then 802.3 is going to be that MAC sublayer and that physical transmission medium, and this is going to determine your bandwidth and your speeds at the actual physical link, right? All right. So again, LLC is implemented in software, and its implementation is actually independent of the hardware. And the reason we put this in there is because whether or not you have a Ethernet cable that only does 100 megs, or you have a fiber connection, right, which is going to have a different NIC, right, than an Ethernet NIC, LLC doesn't really matter. Its whole job is to bring those upper layers to those lower layers, right? Bring that IPv4 packet to be encapsulated properly into that layer 2 frame or that data link frame, right? Now let's jump into the MAC sublayer or the media access control. So this is going to be what we're familiar with, right? The MAC address. So the MAC sublayer is the lower sublayer of the data link layer, and this is implemented in the hardware. So what do we mean by this? The actual NIC or the actual Ethernet port, that hardware there, is actually going to have what we call a media access control address. And this is actually burned into that hardware. Now, for some of you that are pretty savvy, right? This isn't your first time talking IT. We know that we can manipulate our MAC address in software, but we're talking the fundamentals here, right? Originally, that MAC address was only implemented via hardware, and it was actually burned into that NIC. Okay, so the Ethernet MAC sublayer has two primary responsibilities, and we're going to deep dive into that. So one is data encapsulation, right? Encapsulating all the upper layers into that frame. And then its second responsibility is media access control, which essentially means getting our data, that frame, to the correct destination. So the data encapsulation process is going to include that frame assembly before transmission and that frame disassembly upon reception of a frame. So in forming the actual frame that we're going to use to send across the wire, we're going to need that MAC sublayer to create our actual frame with the destination and source address. Okay, so now let's get into the data encapsulation part of our two primary responsibilities. So it's going to have three primary functions. The first one we're going to talk about is frame delimiting, and essentially all that is saying is we have these groups of bits that identify the frame, right? So these delimiting bits provide synchronization between the transmitting and receiving nodes, okay? And then we have addressing. So the encapsulation process is actually going to contain that layer 3 information, or PDU, which stands for protocol data unit, right? And it's also going to provide the data link layer addressing, that addressing being that MAC address. And we're going to get into what that MAC address is later on in these slides. And then we also have error detection. So in that Ethernet frame, right, when we encapsulate it, we're going to have a trailer, and that's going to be our FCS, our frame check sequencing, to detect any errors in our transmission of that frame. Okay, and then actually we can actually see a MAC address burned in here. So sometimes it's referred to as the BIA or burned in address. I know when I've gone through the Cisco Networking Academy, they use this term a lot. You're not going to see it a lot in, your daily life as a network administrator engineer. People just say the MAC address, right? But another important thing to note, this sublayer, the MAC address sublayer, communicates directly with the physical layer. And this MAC address gives a unique identity to that physical layer component, which is generally the NIC, if we're talking your computer, or the Ethernet port on your switches. So now let's kind of dive into the actual Ethernet frame and take a look at it. So if at the data link layer, the frame structure is nearly identical for any speeds at Ethernet. So whether this is regular Ethernet speeds at 10 megabits or gigabit, you're going to generally have the same exact frame, okay? And the same field size. So as we can see here, we have 8 bytes for the preamble of this frame. And then we have the important part here of the frame. Well, it's all important, right? But this is going to be that MAC address sublayer where we have a destination MAC address and a source MAC address in this header right here, this Ethernet header. And then we have these types field, which is bits that, those delimiting bits we talked about. And then we have our data that's encapsulated into this frame, right? So that's all of our application data. And then we have this frame check sequence here, which is 4 bytes, and that's going to do our CRC checks, right? Also our trailer. So the minimum Ethernet frame size is going to be 64 bytes. And we kind of discussed this in our layer 1, where anything under 64 bytes is considered a runt. And then the maximum is going to be 1,518 bytes, with our MTU size for our data typically being 1,500, right? And this includes all bytes from the destination MAC address field all the way through the FCS field. So any frame less than 64 bytes in length is considered a collision fragment or a runt frame. And those are automatically discarded by the receiving stations. And then anything over 1,500 bytes of data is going to be considered a jumbo frame. I haven't heard this baby giant frame, but again, when you go through documentation, the IEEE, building this course, it's vocabulary that's there, right? So we have to mention it. Okay, now we just have a little chart here to go over the differences and see if we know them, right, between the LLC and the MAC sublayer. So, number 1, it says controls the network interface card through software drivers. And again, sorry, feel free to pause, try to answer this yourself as we go over it. So that's going to be LLC. Remember, LLC is independent of the hardware. Doesn't matter if you're using fiber or copper. It is implemented in software. So this answer is LLC. Number 2, works with the upper layers to add application information for data delivery to higher level protocols. Again, that's going to be LLC. LLC is going to work with our upper layers in encapsulating or bringing that network layer 3 PDU to be encapsulated in our layer 2 frame. Number 3, works with hardware to support bandwidth requirements and checks errors in the bits sent and received. So this is going to be our MAC sublayer, because again, MAC addresses are implemented in hardware, and they're going to support our actual Ethernet technology, 802.3. Remember, 802.3 is going to determine our bandwidth. Okay, and number 4, controls access to media through signaling and physical media standards requirements. That's also going to be our MAC sublayer. Again, 802.3 is the standard we're going to use to determine how we signal on the physical layer and the media standards requirements. And then number 5, supports Ethernet technology by using carrier sense multiple access collision detection or carrier sense multiple access collision avoidance. So we haven't actually gone over this yet. When I was building this slide deck out, this was part of my CCNA in-person course, where I kind of go over this on the whiteboard. But we'll go over this in later, I think in the next video. So it's okay if you don't understand that for now. That is going to be the MAC address sublayer, and we'll cover this vocab and what these are later on in the course. And then number 6, remains relatively independent of physical equipment. That's going to be our LLC sublayer, because again, that is software based, okay? I wrote software terribly there. Sometimes I have really bad handwriting on this stuff. Let me fix that for you guys. Remember, LLC is implemented in software. Awesome. Okay, now let's go over the actual MAC address structure. So if you've been following these videos in chronological order, you know we've already been over hexadecimal, going over IPv6, but we're going to talk about it again for our MAC address structure. So an Ethernet MAC address is 48 bits, And these 48 bits are going to be organized and expressed in hexadecimal digits. And we know for hexadecimal, these digits are represented by 4 bits. So our MAC addresses are going to be 0 through 9 and A through F. And they're going to be 48 bits. Now, if we split up the MAC address, the first 24 bits are going to be vendor specific, and the last 24 bits are going to be unique to the actual device. I believe we cover that here in this next slide, what I'm talking about. Cool. So the MAC address values are direct results from the IEEE enforced rules for vendors. And these rules are, without reading the IEEE standard verbatim, is essentially that the first half of your MAC address is going to be an OUI, an organizationally unique identifier. So if you have 7500 Dell Precision laptops, they should all have the same OUI. Then the second half of the last half of that MAC address is going to be the unique part that is assigned to that NIC per device, okay? So as you can see here, we have a nice little chart to kind of describe this. The first 6 digits are going to be the OUI, and the last 6 are going to be unique. So when we are like searching for a MAC address on our layer 2 environment, this is going to make more sense to get to the CLI. You want to search using these last 4 digits, or those last 6 digits, because those are going to be the unique ID of the actual device. Okay, now let's get into a little bit of frame forwarding. And we're going to dive a little bit deeper into this in our next section when we go over switching fundamentals. But for now, we're just going to do a quick overview. So we've been talking about our frames, our Ethernet. Well, how do we actually get them forwarded? How do these computers, these switches interact to know where to send these Ethernet frames? So source and destination MAC addresses are going to be used to forward the Ethernet frame. Okay? So if this is the sender right here, or the source, or sender, it's going to create a frame and say, hey, I want to talk to this MAC address. And it's going to send it over its transmission medium. And again, we're just being transparent here, not getting into switching fundamentals just yet. Once it sends that frame, every single device is going to receive it. And again, this is just transparent. And it's going to look into that frame and say, oh, that destination is not me, so I'm not going to send any information back. And then this guy right here, we'll call this computer B, says, hey, this is mine. So this is how you forward frames. It's based off the destination and source MAC address. And we get into switching, we're going to show you how when we plug in endpoints to a switch, how the switch builds that MAC address table for frame forwarding. And then we have 3 different types of MAC address, or 3 different ways we forward these frames. And let's jump right into this. So we have a unicast MAC address, which just means one-to-one communication. You're just sending it to one device on your network. We can see here, this is the client trying to talk to the server. And this is the entire Ethernet frame. You can see this layer 2 header encapsulating the layer 3 header, right? And it knows the destination MAC address to that server. And then we have a broadcast MAC address, which is going to send that Ethernet frame out to everyone on that broadcast domain. So we can see here that when you send a broadcast frame, again, our layer 2 header here, layer 3 header, the entire frame. The destination MAC address on a broadcast frame is going to be all Fs. And as well as the destination IP is going to be the broadcast address, which we're going to get more into in layer 3, right? But the important thing to know for that broadcast MAC address is that the destination is going to be all Fs. And in that payload right here is going to be asking, hey, I'm actually looking for a specific client, but the switch doesn't know where that client is. So respond if that's you that I'm looking for. And we'll get into that more in switch forwarding. But the important thing for this slide is that you understand in a broadcast MAC address, it's all Fs in the destination field of that frame. Then we have multicast. So the multicast MAC address is a special value that actually has this at the beginning in the hexadecimal. And then the remaining portion of that multicast MAC address is created by converting the lower 23 bits of the IP multicast address into hexadecimal characters. And that's how we create a multicast MAC address. If you ever get into your CCIE training, you're going to learn a lot about multicast addressing. And this is where you kind of learn layer 2, layer 3 multicast. But just for the CCNA, I just want to kind of give that bullet up there to show you that a multicast MAC address is unique than a unicast and a broadcast. Okay, awesome. So we just went over the Ethernet fundamentals. Stay tuned for our next video. We're going to get into switching fundamentals. And thank you for viewing this video.